No,
Pending
narinig
pa.
ka na, Debe.
Hmm?
Pending.
Ayun,
Started
okay na.
recording. So, good day. We are the Group 4 for CPE 107L Section B2. So, for Project 2, uh, we'll be discussing different parts of the project which we have created. So, next slide, please. So, to start off, we started with circuit building. Next slide, please. So, we actually modified Project 1, which is this circuit you can see in the slide. So we modified this by adding different variables, which include registers and counters. Next slide. So
Ah,
for registers, Miguel de Veradurda will be discussing the modification made.
okay. So for this one, we choose the register the parallel input and parallel output. This circuit consists of using the modified T flip-flop. So we use this circuit that we have made from Laboratory 6, and we modified it to with an additional bit input, and we have also added another input pin that serves as our clear. And for the next one, and this is the application for the EPO register. And as you can see, the register is connected to the output of the incrementer, and the output of the register is connected to the input of the incrementer. And as you notice, this is like ano to? Magiging loop siya. So it will increment depending on the that depends on the clock pulse. Uh, yun lang naman, no?
So for the proper functioning of the register, which was mentioned a while ago, the people shift register, we actually added other variables. So as you can see, the encircled variables here. So there are actually four besides the people itself. So we added the NOT IC to enable the functioning of the people. We added the AND and XOR so that the output will stop at 32, which is the last number of the range in the table seen earlier. So we also added a button to clear this output. So that's the other variables added for the proper functioning of our registers. So now moving on to counters, may I call on CJ Tichwako?
Nakamute pala ako. So, so the final addition to Project 1 is this decade counter circuit, and it uses a uh, four counters using the D flip-flop, as you can see in the schematic diagram. And the outputs here are all in BCD format. So the first 4 bit outputs on top are all sent into the hundreds position. The next four are the tens, and then the last four are the ones bits. And that final output, as you can see at the bottom, connected to the XOR gate, is actually the enable uh, signal that will be used for the people and the AHI counter display. So it will properly display only after the timer has hit 180. And so, next slide, please. There you can see in the top left that is the counter circuit that was displayed earlier. and each BCD output is wired to its corresponding 7 segment decoder. So it will convert the BCD inputs into the corresponding 7 segment display signals. And so that's all for the additions to our uh, Project 2 circuit. And moving on, we will see the output simulation in the next slide.
Okay.
So for our output simulation, we've actually pre-recorded a video to show the um, to show whether or not our project 2 is functioning properly. So as you can see, we made sure that the outputs are within the range of 0 to 5, and the 7 segment decoder should show us a value of 0 for this specific given. So we actually clear the timer or the clock, and then manipulated the threshold to check whether the different different values would give different displays. So for this one, we actually get a value of 0, 0, 0, 1, 1, 1, which is within the range of 6 to 10. So it displayed the value of 1. So here's another example, 0, 0, 1, 1, 1, 0, which is within the range of 11 to 15 and should show a display of 2, as seen in the video. So once again, we actually get the value now of 0, 1, 0, 1, 0, 0, which is now within the range of 16 to 25, and it should show a value of 3 in the 7 segment display. Now for our last trial, we'll once again manipulate using the threshold, and we'll use the value 1, 0, 0, 0, or 32, which is the last number for this project. And we should get a value of 4, or a severity of 4 for our 7 segment display. So that's it for our output simulation for project. So moving on, we will be discussing our conclusions on the objectives and challenges encountered. So first, we'll have Miguel's conclusion.
Uh, so for the objectives, we actually integrated our circuits that we have made from the last laboratory 6 and laboratories 7, which are the register, the parallel in and parallel out circuit, and the counter. And for my challenges, uh, one of the challenges that I have encountered is when designing the circuit to have additional ICs to meet the condition for the output of the register, because last time, upon the upon reaching the 180-second mark, is patuloy-tuloy pa rin yung output ng register, nag-i-increment pa rin. So nag-design kami na ma-meet yung condition na mag-i-stop yung register kapag na-reach na yung 180-second mark. And that's it for me.
So, for my conclusion on the objectives and challenges encountered, I think that we were able to execute what um, was needed to be done in Project 2, which was the modification of Project 1 by adding additional variables, which include the uh, projects in Lab 6, which is the registers, and Lab 7, which is the counters. So I think by modifying previous projects to fit our project one and have a working circuit, I think we were able to execute the project two well. So for the challenges encountered, I think one of the most common problems we that all of us actually encountered while doing the or building the circuit was bugs and errors in the Logism application. So we actually had to restart the file several times to ensure that the circuit will function properly. So that's it for my conclusion. So
So for my conclusion on objectives and challenges. So for my objectives for Project 2, I think my objectives would be that to apply the knowledge that we have gained from this module 2 into a pre-existing circuit that we have created during module 1 and to properly integrate it to add more features and usability in more flexibility in more fields. And so for the challenges that I've encountered in this project is the uh, first of all is the display of the counter circuit. So the original display of that is a BCD output and it's very hard to interpret since it's hard to convert binary to decimal very quickly. So what I did was I had to make a new encoder from scratch just to allow the user or even us to easily debug and check if the timer is working properly. And so after that, another challenge I've encountered is the uh, addition of an enable signal in to the counter. And so I had to find for ways to add a enable signal that will stop the circuit at 180 and also enable the people and the AHI counter display. So that's all for my challenges for project 2.
so that's it for this discussion on Project 2. So thank you for listening. Once again, we are Group 4 of CPE 107L Section B2.